Have you ever wondered how we could make quantum computers more reliable and less prone to errors? Welcome to the fascinating world of topological quantum computing. Imagine a quantum computer that's naturally protected against errors, like a fortress guarding precious information. But how does it work? The key lies in topology, the mathematical study of properties that remain unchanged under continuous deformations. Think of it like a coffee mug transforming into a donut. They're topologically equivalent because they both have one hole. What makes topological quantum computing different from traditional approaches? Unlike standard qubits that are vulnerable to environmental noise, topological qubits are protected by their very nature. They store information in a way that's spread out across space, making them immune to local disturbances. But how do we actually create these resilient qubits? The answer lies in exotic particles called anyons, quantum particles that can remember their past interactions through their topology. These anyons form braids in space-time, and the pattern of these braids stores quantum information. Why should we care about this approach? Topological quantum computing could be the key to building practical quantum computers that don't require extreme conditions to operate. The stability of topological qubits means less error correction is needed, potentially making quantum computers more scalable. Further reading. 1. Introduction to Topological Quantum Computation by Pachos. 2. Microsoft's QCR documentation on topological quantum computing. 3. Quantum Computing, A Gentle Introduction by Eleanor Riefel. If you found this video helpful, don't forget to subscribe. We post new quantum computing content every day.